And here we are, day number 3. We are live on air for ANZ Coders. Welcome again for another fantastic session. Hopefully you're not missing out on the footy. You can always record that and come back and watch this later, which is great. I'm feeling a bit under the weather, so I'm going to minimize my talking other than to say thank you again to our sponsors, Redify and Crowdcast. And I'm going to hand straight over to Mr. Filip Ekberg, who's going to talk to us about the future. Dun, dun, dun. Filip, it's all yours.
Thank you so much, Richard. Good evening, everyone, and good morning, I guess, and good night to everyone around the world. So let me get my screen shared here, and I'll start talking about the future of C#. So I don't want to alienate anyone that is doing F# at the moment or any other programming language. There are a lot of you out there that probably already do C# and a lot of Java or F# or Haskell developers. So I want to talk about why C# is going to be really important for the future. So I'm Filip Ekberg. I'm an author, blogger, speaker, C# MVP, and just a general geek, I guess. I do work at a place called Invoice2Go as a senior software engineer. C# is my day job, and if you have any questions during this talk, please feel free to write that in the Crowdcast chat or ping me on Twitter, and I'll try to answer as many questions as possible. So C# through time has had a lot of interesting changes. We got C#1 over 10 years ago, and it's been a lot of changes since then, looking at what we have today. So I kind of want to spend some time talking about how C# has been evolving and kind of what we can expect from C# in the future. In the beginning of C#, it was released as an imperative programming language. Over the years, though, they've added kind of styles from declarative programming languages and functional programming languages. So if you're new to C#, you'll find that you see similarities with F# and you see some similarities with SQL if you're doing LINQ. And we have, of course, the imperative programming, which is the fundament to C#. So if you're coming from a different programming paradigm, you will certainly find yourself comfort in a few different places in C#. So looking at how C# evolved over the years, after the first release of C#, we kind of got a lot of new features. C# 1.0 kind of gave us the fundament to stand on to start working on C# applications. So in C# 2.0, we got generics, we got iterators, we got nullable types, which were kind of the biggest features released with C# 2. We also got things like partial types, anonymous methods, getters and setters with separate accessibility, static classes, and a few more things. So you can kind of see here that during the early days of C#, it kind of evolved into programming language that a lot of us came to love. And with C# 3, we got more things. And one of the funniest thing here is that when they introduced implicitly typed local variables, one of the first things that my previous coworker said to me back in Sweden was that this is now a dynamic programming language. Never use the var keyword because that's going to be dynamically invoked. Of course, they were wrong about that. And C# is still statically typed. But this introduced a way for us to not having to be explicit. We started to write code that is more readable and maintainable. We also got auto properties. We got expression trees and lambda expressions, and a whole lot of other things that made it possible for us to do language integrated queries and nice expressions. We got anonymous types and a few more things. So we see here, looking at C# 2.0 and 3.0, we see that the language team worked on getting a lot of features into the programming language. Looking at what happened between C# 3.0 and 4.0, we can see that we kind of got a bit less amount of features added to the programming language. So something happened between C# 3.0 and 4.0, and as a bystander, you might think that, well, maybe the language is completed now. Maybe there's nothing more to add to it. Can we just be happy about that? Well, C# 4 introduced dynamic binding, which is by no means a small feature to add to a programming language. We also got named and optional parameters and generic encode and contravariants. But we see here that the amount of features added to the programming language is actually less than what we got in 2.0 and 3.0. And C# 5 actually introduced even less amount of features, but asynchronous methods is really something that we shouldn't really take lightly. I could spend hours talking about how to write asynchronous code and how to do that properly. So adding that to the existing compiler was probably not the easiest task for the language design team at Microsoft. it really helps us writing better applications. So with each iteration of C#, when we got generics, we got implicitly typed local variables, we got named and optional parameters, and then asynchronous methods. All of these helps us write better applications and write applications that are more maintainable and easier to read. So looking at how this will kind of change in the future and understanding kind of what happened between C# 3 and 5. So there's a reason for the kind of lack of added features in the newest versions of C#. And that's kind of because Microsoft started working on a new compiler. This compiler has, over the years, been referenced to as Roslyn. It's now known as the .NET Compiler Platform, and it's a rewritten version of the C# and VB compilers. So Microsoft decided many years ago to start reworking the compiler, and just imagine yourself having a code base that is 10 plus years old, and you need to maintain this, and you need to add new features to this every iteration of the language. It kind of gets a bit difficult, I guess. So what they did was that they rewrote the new compilers in C# and VB, which is really awesome because they get to use everything that you can do in a managed language. And compiling things with the new compilers is quicker because you can compile things directly to memory. You don't always have to go to disk, which is also increasing the performance of the compilations. And what happened when they started rewriting compilers is that since we're doing this in a managed language, they can write tests, it's easier to extend, and it's easier to maintain. And looking at how developing applications in general from the beginning of when I started coding over 10 years ago, and looking at how we develop applications today, it's more about trusting the compiler to solve complexity for us. A lot of years ago, when I started programming, one of the things that people tended to not want me to do was not use libraries that were already out there. Today, I would never think twice to re-implement something that someone else had implemented already. I pull in a NuGet package that someone else built. I expect their functionality to be proper and tested, but maybe 10 plus years ago, that wasn't really the case. So looking at how this changes is that we can now trust the compiler to solve complexity for us. And this also ties into us being less verbose. So we're getting syntactic sugar, like the async and await keywords, which helps us avoid complexity in our applications. We don't have to do the state machines ourselves. The dynamic keyword is there to help us writing dynamic applications. And we can be less verbose in our applications, but having the compiler introduce this complexity for us. So we're kind of entering an era where we are saying, I want to solve a problem. I don't really care about the nitty-gritty behind the scenes. Just solve that for me. So I smack on the async keyword on my method and use the await keyword, and I expect my application to behave accordingly. And one of the best things about the new compilers is that it's open source. It's not only source open, which means that Microsoft is actually working openly on this. They allow you to do discussions on their GitHub page. You can follow the progress of the language, and you can follow the progress of the languages itself. So I've kind of talked about what the new compiler is doing and kind of how C# has transitioned. So let's talk about C# 6. C# 6 introduces quite a few features. And since the first announcement of C# 6 and kind of the Roslyn compiler, and when they released that to CTP and so forth, they've changed the features in the language. But since Visual Studio is now in a release candidate, we can hope that the features that I'm going to talk about here today is the final ones that we will see in the language. So one of the first features that they're adding in the new language is using statements for static members. And using statements for static members is something that will kind of make our code a bit more readable, but it could also potentially add a few problems in our code. So look at this simple portion of code here. I'm doing a console.writeLine. I'm going to write out the sign of the angle 90, and we can simplify this a bit with C# 6 by kind of reducing this amount of the amount of code on this line here. So what I can do is that I can simply say that I want to use all the static members or the static methods from system.console and from system.math, and I can change these two method calls at the bottom here to writeLine and sin. And this is just a small example of something that is making our code more readable. So what it's doing here is that it's finding where writeLine is introduced, and it's looking for that in system.console. Imagine if we change that to debugging instead. That would mean that instead of writing out to the console, it would now write out to the debugger. So here's another example where we use system.link.enumerable instead. So now we can say that we are going to get a range from 0, and we're going to get 10 numbers. So this here is another example of how we can introduce a static member and kind of simplify our code a little bit. Now I want to talk about these language features because they kind of represent where we are going with C#. Between C# kind of 3, 4, and 5, you might have thought that, okay, the language team isn't going to be more involved in writing new features. They're not going to invest as much time in writing more features here. They're going to move away to F#, which is what is the correct way for me to go. So I just want to show you all of these language features to kind of give you an indication that C# is definitely not dead, and it's definitely something Microsoft is working hard on. So auto properties have been around for a long time. This is a normal auto property in C# where we have a getter and a setter. But the problem here is that what happens if I want to have a getter only? In this case here on the bottom, I'm using something called an auto property initializer. So I have my class person, and I have a name that is read-only. Now, previously, if you wanted to do this, you'd have to introduce a backing field. You'd have to return that backing field manually within your getter, and then set the backing field accordingly in your constructor. So this is a bit of a nicer way for you to set your auto property, or to initialize your auto property directly in your class. And this also works with inside your constructor. So if you have a getter-only auto property, you can set the value from the constructor, and this will create a backing field for us in the backend. So kind of looking at what this is doing behind the scenes for us, because mostly what the compiler is doing is that it's rewriting our code into C# code that has been around and has been understood by the runtime and in IL for a long time. So we're doing a private read-only string here, which is the backing field. We're setting that to Filip. So this is a true read-only auto property. The next feature that Microsoft is introducing is await inside catch and finally blocks. I've been doing asynchronous programming for a while now, and I've been talking about asynchronous programming for a long time. And it really excites me when Microsoft invests time in improving how we use asynchronous programming. So looking at this method here, it's a download async method. It's expecting us to do a few awaits in it. And in this case here, we are getting an exception. So let's just neglect what is happening inside the try block and just assume that we're doing something that is asynchronous. In the catch block and finally block, we can finally do await. We can do await, and we can clean up resources after ourselves when we are inside this state here. So imagine that you're getting an exception from invoking a web server. You might want to clean up some resources or write something to disk. And disk operations nowadays is mostly asynchronous. So that means that you can now do the await inside the catch and finally. This is probably one of my favorite features. Microsoft is introducing something called the null-conditional operators. It's also known previously as the null propagation, and is commonly talked about either as null propagation or null-conditional operators. It's a really nice addition to the language, which is going to help us avoid null reference exceptions. It kind of goes back to the base problem of C#, which is why they're allowing null from the first place. If C# didn't allow us to do nulls anywhere, we wouldn't have null reference exceptions. Now, it would be kind of a big impact if we were just to say that you can no longer do nulls inside C# or inside .NET applications. So instead, we're going to make it easier for developers to catch these problems earlier. So the null conditional operators kind of allows us to check if something is null before we go ahead and go further in the line of either method calls or property getters or setters. So in this case here, I have a person, which has a name and an address. I'm creating an instance of this person, which is called Filip. So Filip here doesn't yet have an address. Now imagine that I want to write out Filip's address, and I expect that the address class itself has an address line 1. I could say that Filip.address, if that's not null, let's go ahead and give me the address line 1. But if it's null, I want to say no address. There's a bit of a bug in this code here, which is what happens if Filip is null. Well, if Filip was passed into a method, for instance, we'd have to first check if Filip is null, then return no address. If Filip.address is null, return no address. It kind of gets a bit ugly. So with null conditional operators, it gets a bit nicer. So we can say here, which is also fixing the bug that I just talked about, we can say, if the address is not null, go ahead and give me address line 1. But I'm also checking if Filip is not null, go ahead and give me the address. If address is not null, go ahead and give me address line 1. And if any of these here are null, it will just evaluate that entire expression as null. So we can use a double question marks and say, if any of these are null, just give me this default value. Another way to look at the null conditional operators is from this small little array of people here. So the first person is initialized, and we can simply say, well, if the first person is not null, go ahead and give me the name. And for the second person, we know that that is null, but we're going to check that anyways here, because this is going to be, of course, a dynamic application. You might be doing this in a for each loop. So we're saying, if the second person is not null, go ahead and give me the name. So null conditional operators doesn't only work if you're doing a property, accessing a property or accessing a method. You can also use it to check if an entire array is null. So in this case here, I'm saying if the people array is not null, go ahead and give me the first index. If that person on the first index is not null, go ahead and give me the name. And all of this compiles down to the code that we see on the bottom here. So it kind of gets a little bit easier to read. So all of these features added to C#6 and potentially added to C#7 and 8 are there to get us to write more maintainable and understandable code. If I add a question mark, I know that I'm asking and saying that this object could be null. I'm going to handle it if any of these operations are null, but I don't have to write that ugly code at the bottom. So one of my final favorite features added to C#6 is string interpolation. I know a lot of people out there have been waiting for string interpolation for a long time, and it's a way for us to avoid doing string.format. I know in my case, I've had a lot of times where I do a string format and I kind of get the order wrong on the objects I pass to string.format at the end, and that kind of messes up the result of the string. So string interpolation is a way for us to say, hey, this is an interpolated string. We're going to say my width is width, and my height is height, and that is going to go ahead and give us the properties or fields or variables, or it could even invoke a method. The good thing, though, is that the compiler is taking care of this for us. So it knows that it needs to compile this down to a string.format, and it's properly aligning the objects passed to this string.format. So it kind of gets a bit more readable. Reading the one on the bottom here saying string.format, my width is 0, we'd have to go over and check the first object passed into the string.format, and then we check the second one and so forth. And it's so easy for us to mix the order of height and width. So the first one on the top here is definitely easier. And funnily enough, I've been using Visual Studio 2015, the release candidates, and that was released. And every day I'm using string interpolation everywhere. Whenever I do a string, I'm using string interpolation because it makes it so much more readable for everyone in the team. And it doesn't only work with field accessing without doing any formatting. So in this case here, I have my variable int age, which is 28. And then I'm saying the result here is going to be an interpolated string. I'm saying that the age needs to be 5 digits. So I can do that nice formatting inside my string interpolation. And this will, of course, say, hello there, I'm 00028 years old. However, when this is compiled, the compiler will, of course, take care of compiling this down to something that is less readable for us. So we no longer really have to care about what this looks like behind the scenes. We can write more readable and more maintainable code and focus on solving problems instead of solving these trivial issues that could occur if we switch the order in our string.format. So there are, of course, more features being added in C#6. That was just some of the favorite ones of mine. I wanted to highlight a few of them and how they work. So a few other features that are being added to C#6 is dictionary initializers. We've had dictionary initializers for a long time in C#, but with this new addition here, we can easily say that we have a dictionary that the key is a string and the value is a person. I can use the key straight away inside my initialization, like I'm doing with a normal object initialization. And the same goes for it if it's an int or whatever the key is. Now, the second one here is something called expression-bodied members. In this case here, I'm overriding the toString method on my rectangle class. I'm combining two language features together. So I'm using this fat arrow to say that I have an expression on the right-hand side. This is an interpolated string, and this will all be compiled down by the compiler to a method, and that method will have string.format within it. But we can use this nice little expression-bodied member instead. So it kind of saves us a few lines, especially if you do things like calculating the area or doing small calculations. Instead of having to create the entire method body, you just do a nice expression. We're also getting something called exception filters. So exception filters is a nice way for us to not have a bunch of if statements in our catch blocks. So in this example here, I'm throwing a custom exception. The severity is pretty high, so I'm saying catch the custom exception. When the exception severity is above 50, I might want to send an email to someone, or I want to have a system that calls me up in the morning and has me go to the computer. And then at the bottom, if there's no exception filters catching my exception, I can catch the rest of them. So that's a very nice way for us to kind of filter the exceptions that we're getting inside our applications. Hopefully, with the null propagation and null conditional operators, we will no longer get the null reference exceptions. So the final one we're getting in C#6 is name of operator. The name of operator is there for us to say that you can get the name of a variable inside your class. And you might ask yourself, why don't you just write the name inside your string? Well, what happens if you do some refactoring? What happens if you change the name of args in this case, for instance? If you didn't use the name of here, you would end up saying, hey, the parameter name is args, and you've changed it to something else, and then the developers will be totally confused. So this is a kind of small example, but for logging and for exceptions, it's really, really helpful, and it's really giving you a lot more information, and it's giving you a lot of help when you are writing these types of things for your applications. And there are potentially a lot more features being added in the future. So we might get a few more features to C#6. Since C#6 is still under development, we don't have a final version of the language out there yet. There has been a few features being taken away from the language over the last, I don't know, 6 months. So I can't guarantee that all of these features will be in the language, but I can say that we could potentially get more. So kind of looking at all of these different iterations of C# on side by side, we see that C#2 and 3 had a lot of features. Then Microsoft potentially or probably started working on the new compilers. They still wanted to add a few big features to the language. And then we got C#6, which is based on this new compiler, and we're getting using statements for static members. We're getting auto property initializers. We're getting await inside catch and finally blocks. We're getting null conditional operators. We're getting string interpolation, dictionary initializers, expression-bodied members, exception filters, name of operators, the name of operator, and potentially more things. So you see here that Microsoft is really back to where they were to start off with. They're adding more features to the language. They're changing it in a way that we as developers can use the language to express ourselves in much nicer code and much kind of less code, really. So what about C#7? What about the future and the potential of what we can get in the next language of C#? So C#7 is really already under discussion. So Microsoft is already talking about the design of C#7. And the features that I'm going to list here, that's features that we've seen in early versions of C#6 and features that have been talked about during the evolution of C#6. And it's things that they do talk about during the design meetings that you can follow on GitHub. So we might get something called binary literals and digit separators, which basically means that we can do binary literals inside our applications. And if we have hexadecimal numbers, we can separate each of the segments by an underscore, for instance. And this kind of just makes it a bit more easier for us to read. I guess it's kind of a limited use case for this, but it's a nice feature to have for those that work with that a lot. We're hopefully getting event initializers. So if you're doing object initialization and you have to set the events, the problem with that is that you have to set the event after your object initialization. And it kind of just gets a bit ugly, I guess. It would be nice to just get that in the object initialization. Another one that we've talked about and seen in C#6 in the past is the field targets on auto properties. So in this case here, I can say that the backing field of H is going to be a non-serialized field. This is probably one of the features that I really want to be added to C#7 the most. It's semicolon operators. So in this case here, we can see the segment on the right here of the equal sign. That's an expression that will be executed as a whole thing. So we're saying that var x is equal to foo, and then we're going to write the value of x, and then what this returns is the x multiplied by x. It's not going to create a function for us. It's not going to be that we have to invoke y to get the result. It's just going to do all this in one go here and give us the result that we have furthest to the right. So it's a nice way for us if we want to do some logging and we want to do some something with the value before we assign that to the variable, instead of having to create a method for us. So there are still ways for us to kind of solve the same, I guess, problem, but this is just a nicer way for us to do that. And if you're working with multi-dimensional arrays, having params for INumerable is really something that I know a lot of people have asked for a long time, and that's potentially something that we could see in C#7. Finally, there are two more things that I hope to see in C#7, and one of them is declaration expressions. So we have this method here called calculate age based on birth year. And this is using an out parameter. Of course, the method signature could just return that as an integer. But as developers, we know that that could happen quite often, that we have an out parameter. So when we're calling this, we would first have to initialize the int before calling the method. Declaration expressions will allow us to do that in one line. So we can say calculate age based on 1987, do an out variable call age. So it's just going to create that for us. Just a simpler way of writing the same thing that we've done in the past, but it's less code and it's more readable. Finally, one of the features that have been talked about a lot when it comes to C#6, and I was really sad when they pulled this out, because I think primary constructors have a nice to have in the language. So we can say here that the class person cannot exist without the name and age, and this is the constructor that we need to create our class. Now, you can, of course, do this if you just introduce one constructor with these two parameters. But this is nice to have in the class declaration to say, you are required to pass these two values to create this object. And these would go hand in hand with auto property initializers. So imagine here, you see that you can set the fields to these primary constructor arguments. You could do the same for auto property initializers. And of course, as we've seen with C#6, there are potentially a lot more features that could be added to C#7. There is really endless potential, and I think that since we can do the language feature discussions on GitHub, we can really get involved in what Microsoft is working on, and we can help them shape the future of C#. The compiler APIs are at your disposal, which means that you could write analyzers and refactoring packages that simply hooks into Visual Studio. Since you have access to the compiler APIs, and Microsoft rewrote the entire compiler in a managed programming language and made a really nice API for that, you can analyze code yourself, you can deploy your own analyzer packages, and you can just use everything that Microsoft is using to make the best tools out there as possible. So looking at C# and how it actually grows with each release, it's really nice to see that it's evolving, and with C#6 and C#7, we are truly getting a lot of features out there, and we're really getting the best that we can expect. So C# is the future. I think it's time that everyone embraces that, because it's really kind of taking everything together, and we have imperative programming, we have functional and declarative programming, and C# is kind of in the center of that. So if you're coming from Haskell, F#, SQL, or C++, or Java, or Python, or Ruby, or PHP, you can find something in C# that you could solve your everyday problem with. I'm not saying that C# is going to be the answer to everything. I'm just saying that C# is going to be here. It's going to stay in the future. It's going to stay current. And we need to embrace that. And we need to start looking at C# for our everyday applications. So thank you so much for listening to me. Again, I'm Filip Ekberg. If you have any questions, I'd be happy to answer those in Crowdcast now. If you don't have any questions, please do feel free to ping me on Twitter. I'll turn the camera back on, and we can start talking about some questions.
Definitely questions. Thank you, Filip.
Oh, thank you.
Okay, so let's run through a few of them.
Yep.
Do you want to read them and just answer them? Because it's probably going to be easier than me talking, because they get to see your high-quality video instead of me and my voice.
So Aaron Powell is asking, what can we expect for C# in the future? F#. Well, yeah, it is actually true that every feature that has been coming to F#, which everyone loves about F#, is kind of making its way into C# in a way. Generics is one of those things that are kind of transitioned from F# into C#, and asynchronous programming has been a part of F# since start, and that kind of also transitioned now into C#. So everything that F# developers love about F# is kind of going to come to C#. Let's see here.
So run through the actual Q&A section rather than the chat. So we've got
right.
Dominic. Do you know how if interpolated strings can introduce boxing, for example?
Sorry, I didn't see the Q&A section here.
That's okay. That's all good.
So Dominic is asking, do you know how and if interpolated strings can introduce boxing? It won't work differently from string.format. So if you're using string.format and that introduces boxing, string interpolation will do the same thing. So I hope that answers the question. It's only going to do translation, right? So it's going to take your interpolated string and just shovel that around and give you a string.format instead. So Alex is asking, does dictionary initializers convert to dictionary.add keyval call method? Is this allowing us to initialize any custom type with add in the same way? So yes, there is coming a way. Let's see if I understand this correctly. So is this allowing us to initialize any custom type with add, like add object A, object B in the same way? So there is coming additions to how you can do add on lists and dictionary, and you can overwrite the behavior of that. And it is in fact calling dictionary.add, or it's doing the so the previous dictionary initializers in C# uses, I believe, dictionary.add, and the new one is doing the key indexing straight away. So it's going to work the same way as that. So any new features that make dealing with iNotify property change simpler? That is a very good question. Not out of the box that I know of. You could potentially use Roslyn to look through your code and rewrite that at compile time. So if you want to make changes to your code, you can use the compiler API, and you can go through your code, and you can go through the syntax tree, and you can rewrite things there. So the kind of the DLLs that you output from your compilation will be different from the ones that you kind of see in your solution. So it's kind of like doing aspect-oriented programming, but you can write that plugin yourself for doing aspect-oriented programming. So Bilal is asking, is there an ETA on C#6? Hopefully C#6 will be released with Visual Studio 2015, which I would believe would be released later this year. I don't have a date for it. It's a release candidate now, and I guess traditionally looking at when Microsoft releases their versions, it might be like in August or October. Let's see here. And what's also, he added to the question, and what's the progress on Roslyn? Is this already in use today or still in development? So Visual Studio 2015 is using these compilers out of the box. So if you download Visual Studio 2015 and you start off a new project for, let's say, ASP.NET 5, for instance, you would be able to use all the language features that I've talked about here today. So that is, in fact, out of the box, and Microsoft is using that in the latest version of Visual Studio. I think that's all of the questions.
Awesome. All right.
Thank you so much.
This is where we do the round of applause thing, the virtual clap inside the chat window.
Yay, thank you.
So thank you, Philip. That was very cool. You rushed through it so smoothly. I was like, what's going on? That's great.
Thank you so much, Richard. It's my pleasure.
It's all good. The community voted for you, not me. Well, I'm not saying I didn't vote for you. That just came out really wrong.
Oh, wow. Wow, that hurt. Wow.
Fail. I'm blaming the drugs I'm taking. Okay, sorry. All right. We will wrap this session up. We're going to have a short 10-minute transition as we lead into the next session. So, guys, grab yourself a drink. Philip will be chatting in the chat channel for any more questions you might have for a few minutes, and then we'll kick the next one off. Excellent. See you in the next session.
Guys.